again here and talk about adding and subtracting rational expressions. So this is kind of another part from R5 that we had started on Thursday. So this is going to be related to when we go to solve these rational equations. We've got to be able to do some things that you have to do in order to add or subtract them. And what we got to remember is when we're adding and subtracting rational things like fractions, the rule is that you have to have a common denominator. Least common denominator is what we're having to do here. So what we want to think about when we think about common denominators is we think about all of the factors that are there. Okay, so let's take like example A. When we were in elementary school, they taught us how to do these things, and they may have taught us tricks to do it. They may have taught us other ways to do it. But what I want us to do is think about it in terms of factors. And what we want to think about is, okay, well, 5, its only factors are 5 and 1, right? So there's nothing else going on. But 20, if you write it in its factored form, it's 4 times 5, right? So it's got two factors there. We could break the 4 apart a little bit more if we wanted to, but we don't have to for this particular problem. So you've got two factors there on the 20. All right. So when we start looking at least common denominator, or LCD is what we'll abbreviate that as, least common denominator, LCD. You want to think, okay, well, what factor does the denominator share? Well, both of them have a 5. So that's automatically in the common denominator. And then you look at the other factors that exist in the problem. So the bottom part of this first one doesn't have any other factor, but this one has a 4. So that means that unshared factor has to be part of the common denominator as well. So the common denominator is going to be 5 times 4. So when you look at your fractions, you say, okay, well, the second fraction already has 5 and 4 both in it. So I don't need anything else there. But the first fraction is missing that factor of a 4. So I'm going to have to multiply by 4. And whatever I do to the bottom, I have to do to the top. That's the rules of adding, subtracting fractions. So if I multiply by 5 times 4 on the bottom, that's going to give me the 20. 3 times 4 is 12 up top. And then the other one is already 9 over 20. Now, because the denominators are the same, I can add the numerators like I did before. 12 plus 9 is going to be 21 over 20. And we're stuck with there. Now, where that changes when we start putting letters in there is the fact that it's just a different factor. When you think about common denominators, it's all related to factors and not so much getting the number the same as it is getting all the same factors in there. If you'll think about it in that terms, I think it makes it easier to do. So let's look at example B, which is a lot like example A. So I'm just added some letters in there. That's the only thing that I've done. Okay, so here we have 3 over 5x squared and 9 over 20x to the third. So when I think about that in terms of factors, I already know that 20 is 4 times 5, and it has 3 x's. And this one has a 5 and then 2 x's. So I think about the factors that exist for the denominators, for the bottom parts of each fractions. So when I look at the common denominator, the least common denominator, I want that shared piece or shared pieces to be part of the common denominator. Well, both of them have a 5 and 1, 2 x's. That's the shared part. Okay, so they both already have those. So I know that I'm going to have 5 and then 2 x's. And then I'll look and see what's not shared. Well, there's a 4 right here, and there's an x that are not shared. Well, I can't take them away. I can only give them to everybody else. I can only pass them out. I can't take them away. So that means I'm going to have a 4. I'm going to put it up there with the 5 because it's a number. And then I'm going to have another x out of that. So my common denominator is going to end up being 20x to the third. What I need to look at then is say, okay, This fraction had 5 and 2 x's. So what does it need? It needs a 4 and another x. So I need to multiply this times 4x on top and bottom. The second fraction doesn't need anything. I don't have to do anything to get the denominator same. I'm going to have 12x over 20x to the third plus 9 over 20x to the third. Now the denominators are the same, so that allows me to say, okay, well, I can just add the numerators. They are not like terms, so they can't be put together. So you write them like this. You write that answer like that's the final answer for that problem. Which sometimes can confuse us because we think, oh, we got to get it to work out to be something. No, only if it's like terms, or is it going to work out to be one thing. Okay, so we've got to look for like terms out of that. Okay, look at another one that's similar to that and change the numbers up a little bit. Let's say we had 3/7 minus 6 over 14x squared. And we're going to write the least common denominator over here, and then we're going to fix the fractions. So when I think about factors in the denominator, I know 14 is 7 times 2, right? And then I've got the x squared. So what factor is shared across the two fractions? That's 7. So that's automatically got to be part of your least common denominator. And then you look for parts that are not shared. There's a 2 and an x squared that's not shared. So my common denominator is going to end up being 14x squared. Okay. Well, what does the first fraction not have? Well, it doesn't have a 2 and it doesn't have the x squared. So that's what it needs, is times 2x squared. We're multiplying that together, and that'll give us a fraction 6x squared over 14x squared minus 6 over 14x squared. And then I combine that to be 6x squared minus 6 over 14x squared. I can simplify a little bit here because the numerator will actually factor. Remember, all the rules, anytime we did fractions in elementary school or anything, we always had to simplify at the end. You always had to reduce your fractions. Same rule still applies here, even though it's got polynomials in it. It's got to be simplified. So when I look at that, I say, okay, 6 and 6. I know there's a GCF of a 6. So that allows me to do that, which then would allow me to take the 6 and the 14 and reduce that because they're multiplied, they're factors, and the common factor in a 6 and a 14 are 2, so that'd be a 3 parentheses x squared minus 1 over 7x squared. And there's the simplifying that can happen with that. And then I just leave that, I'd still leave that 3 hanging out. You could distribute it and get 3x squared minus 3, but it doesn't really help you to do that. So I'm just going to leave it parentheses with it there at the end. Technically, x squared minus 1 could factor as x plus 1 and x minus 1, but it doesn't help you. So that's why I didn't do it. Okay. Let's look at one that has more of a polynomial feel to the denominator. Seven over x minus 5 minus 3 over x minus 5. This one's nice. It's still rational expressions, and we're subtracting them. Same rule for addition, but the denominator is already the same. It's x minus 5. Because the denominator is already the same, I can go ahead and do the work. 7 minus 3 over x minus 5, and I know 7 minus 3 is 4. And I'm left with that as a final answer. I didn't have to do anything to get a common denominator on that one. So it was a little easier. Okay. So when we're having a common denominator, it's got to match up. X has got to be in the front. Notice that the denominators that's in descending order when it's got that addition. And that's important that you have it in descending order, because they may throw one at you like this. And these are the ones that sometimes can get some folks confused, because it looks similar and you feel like your eyes are playing a trick on you. I've had students in the past that have dyslexia, and in their mind it looks exactly the same, and it's not. So you've got to be careful about that. So here we have x minus 3, and then this is 3 minus x. So that should be a flag going up in my, flares shooting up and saying, hey, that's not in descending order. So I need to rearrange that part anyway, so that my polynomials are always in descending order, no matter even if they're in fractions. So that's one thing that can help here. So I'm just going to rewrite the problem, and I'm going to rewrite it with negative x plus 3. That's exactly the same problem. Nothing has changed except for the order that the denominator was written in. And then we see there's a small difference in those two. That is x minus 3, and this is negative x plus 3. And I think, I wonder if I could factor this second one and get it to look the same. And you can, because if I factor out a negative 1, negative 1 times what gets me negative x? Well, x. Negative 1 times what gets me 3? Negative 3. So that denominator now, because I put it in descending order and I see that it's so similar to the first one, that's what tells me to try that. Okay, so anytime you see a negative in front of the variable, you want to think, hey, it might be that little trick. Won't always be that trick, but a lot of times it is. And then that shows me, hey, I've got some stuff that's the same. Those both have an x minus 3 in the denominator. What's the first fraction missing? The negative 1, right? So my common denominator would have the x minus 3 that they share, and then there's this negative 1 that's different. So it's going to be part of the common denominator. So the first fraction, it needs the negative 1 multiplied top and bottom. So that gets me negative 6, negative 1, x minus 3, plus 4, negative 1, x minus 3. So I'm using that factored form on the denominator. And I'm going to do that math. Negative 6 plus 4 over negative 1, x minus 3. So I'm just combining it into one problem because the denominators are the same now. And that negative 6 plus 4 would be negative 2. And then I can simplify then, because remember, we got to reduce fractions as far as they will go every single time. Negative 2 and negative 1 are both divisible by negative 1. They'll divide in evenly there. So negative 1 goes into negative 2 times and leaves the x minus 3 on the bottom. Okay. There's a couple of different ways to do that, but that's the way I think shows the factoring as being an important part of that. I think that helps with that problem. Okay. So anytime that the denominator is not in descending order, put it in that order, and it usually will lend itself to factoring then to get there. This one. 4 over x minus 3, parentheses, x plus 5, plus 6 over x plus 5, x minus 3. Excuse me, x minus 5. Sorry. 5, not 3. Read my own handwriting there. 4 over x minus 3 times x plus 5 plus 6 over x plus 5 and x minus 5. Okay. So here, this one has denominators that are already factored for us. So we don't have to, and they're in descending order. So everything's already kind of done for us there. So we want to look at the least common denominator and see if we can find that. Okay. So we look first to see what do they have in common. What's common between the two fractions? Well, they both got this x plus 5. So that automatically shows up in the common denominator. And then I need one of each of the things that is not common. I got an x minus 3 and I got an x minus 5. Both of those got to be in there. So this common denominator has 3 factors. X plus 5, that's the one they had the same. And then it had x minus 3 and x minus 5. Those were the two that weren't the same. Okay. So if the common denominator is all 3 of those, what does the first fraction need? What's it missing? Well, it's got the x minus 3, and it's got the x plus 5, so it doesn't have the x minus 5. So it gets multiplied by x minus 5. The second fraction, it has the x plus 5. That was the common one. It has the x minus 5, but it does not have the x minus 3. So it gets x minus 3 on top and bottom. Now all 3 pieces are in both denominators. They may not be in the same order, but that doesn't matter because it's multiplication. Okay. Now we can do the math problem. We can put distributed property happening on the top. So that's going to be 4x minus 20. And then the denominator, x plus 5, x minus 5, x minus 3, plus 6x minus 18, x plus 5, x minus 5, x minus 3. When I put that together, 4x minus 20 plus 6x minus 18. I'm writing an extra step in here. I would probably expect y'all to, at this step, just put your like terms together. I'm writing that extra step where we put everything on the top, just so, we can talk about it and see where everything is coming from. So I got like terms in the numerator. I got 4x plus 6x, 10x. I got negative 20 minus 18, be negative 38 over, and then that denominator is still x plus 5, x minus 5, x minus 3. Now, the numerator for this one would factor a little bit because 10 and 38 are both divisible by 2. And if I just, over on the side did 5x minus, let's see, that'd be 19. I can see that it won't simplify. So this factors as that, but it doesn't simplify anything out. So I'm just going to leave it the 10x minus 38. Okay. So when you're trying to simplify, factor and see if something will. If it won't, you can go back to what you had before. You don't have to leave it in that factored form. Most of the time, you're not going to see, if nothing cancels, you're not going to see it, in factored form. Okay. All right. Not bad. So everything was factored at the beginning on that one before we started. Well, let's go to one that's not, where we've got to do the actual factoring ourselves. So let's say we had 7 over x squared plus 4x minus 5 plus 10 over x squared minus 25. All right, so we're going to take each of the denominators and try to factor them. So we got to use X method for the first one. Negative 5 had to be 4. 5 and negative 1. Because it's got a 1 in front of x squared, I can go straight to the factors. X plus 5, x minus 1. So there's the factored form of the denominator. X squared x squared plus 4x minus 5 turns into x plus 5 and x minus 1. And then when I go to the other fraction, the denominator is x squared minus 25. That's a difference of squares. X squared minus 5 squared. So that's x plus 5 and x minus 5. So now I can start looking at the common denominator for that because I've got the denominators factored all the way. Okay? You're always going to factor the denominators if at all possible so that you can find the common denominator. Well, they both share an x plus 5. But then they have pieces that don't match. So I need one of each of those. So the first one has the x plus 5. It has the x minus 1. It needs an x minus 5. So top and bottom get multiplied by x minus 5. The second fraction has the x plus 5. It has the x minus 5. But it's missing the x minus 1. So I'm going to multiply by x minus 1. And then I'll distribute on the top. 7x minus 35 plus 10x minus 10. And then I'm going to go ahead and just shorten up a little bit here and just put that as one big fraction over that common denominator, x plus 5, x minus 5, x minus 1. Because I did the work to make that happen. Now all I got to do is simplify the numerator. 7x plus 10x, 17x, negative 35 plus negative 10 be negative 45, x plus 5, x minus 5, x minus 1. $17 and 45 don't have anything in common, so that won't factor at all on the top. So I'm done with that, and that's all there is to that one. So common denominator, the key is factoring and getting stuff the same. Okay, common denominator, the key is factoring, getting things the same. All right. Now we start looking at equations with the next section. It's exactly the same thing because the equations are going to have adding and subtracting in them as well with rationals. So let's just dive into that because it's all the same skill. That's why I put them all together with this. So 1.6 rational equations. All right. Now, let's say we had a rational equation. Let's just start, just dive right in. 2x minus 3 over 2 plus 5x over x plus 1 equals x. So definitely a fancy looking problem that I've not met very many people that could logically solve that without knowing the mathematical processes to do that. Very, very few folks can do that. Regular equations that don't have the fractions with the x's in the denominator, a lot of folks can kind of figure it out, not actually do the steps. I hadn't met many people that can do this. So the key is getting the common denominator here. And what you want to do is if there's a piece that isn't written like a fraction, turn it into a fraction. So I'm going to put that x over 1 so that everything's a fraction. And then look at the denominators and see, can I factor any of them? So I got a 2, I got an x plus 1, and I got a 1. Can any of those factor? No, they can't. So what that does is if nothing will factor, then I automatically know that the least common denominator for all those fractions is just multiply all three of them together. 2 times 1 times x plus 1, which ends up just being 2x plus 1, like that. So the common denominator, least common denominator here is 2 parentheses x plus 1. Now, when we were doing functions earlier, we had this the idea of the domain, and there were x's that we had to leave out. When you're dealing with equations, there are x's that you have to leave out, and they come from the common denominator. They're called excluded values. Excluded values come from setting the denominator equal to 0. So excluded values. And the key is set the LCD, least common denominator, equal to 0 and solve. So we're setting 2 parentheses x plus 1 equal to 0. And we're going to solve that problem before we work on the real equation. Because what this does is it tells us what answers don't work. So if we find an answer that matches one of these excluded values, we know, I throw that one away. It's extraneous. It's extra. We don't need it. Didn't work. So we're going to solve this equation. So I'm going to divide by 2. I don't need parentheses anymore because I got rid of the 2. And then I get x plus 1 is equal to 0. Subtract 1. X cannot equal negative 1. It is exactly the same thing as finding the domain of the function. Okay, it's no different. The only thing is it comes from the common denominator of the equation. Least common denominator, find it, set it equal to 0, solve them, and then you got your excluded values. So if we get negative 1 as an answer at any point in this problem, we're going to throw it away. We're not going to, we know it doesn't count. Okay? Now let's go back up here and fix this equation with that least common denominator. Okay, the least common denominator, remember, is 2 parentheses x plus 1. So the first fraction needs what? It needs an x plus 1. So I'm going to multiply by x plus 1. Top and bottom. And I put the 2x minus 3 in parentheses so that I remember, hey, I'm multiplying that whole thing by x plus 1. Second fraction needs what? It's got the x plus 1 already, so it needs to have a 2 on there, right? So I'm just going to multiply by 2. Okay. Now, if it was just an addition problem, I would do that and work it out. I'm done. But it's an equation. I've got another fraction over here. What does it need in the bottom? It needs the 2, and it needs an x plus 1. The top and bottom get both the 2 and the x plus 1. Now, we see on the denominator, we got a 2 and x plus 1. We got a 2 and an x plus 1. We got 1 times 2 is 2 and an x plus 1. We've got the denominator all the same. We've done the hard work for getting the denominator the same. We did this extra work over here to find those extraneous solutions that exist, that if we get a negative 1, that we know we're going to throw that out. What that allows us to do is then just take the numerator equation. The numerator equation is the top part of everybody. So we have 2x minus 3 times x plus 1 plus, that plus sign comes from that plus sign in the problem, 2 times 5x equals 2 times x plus 1. So I'm just multiplying across the top there. I don't worry about the denominator anymore because I've done all the hard work to get the denominator taken care of. I found that excluded value. So I'm done with the denominator once I get them all the same. And I do this numerator equation, which is a polynomial, which is something we've solved before. So we're going to do the work to solve this polynomial. So to solve this polynomial, I got to multiply out all these multiplication problems here. So I got to multiply out 2x minus 3 times x plus 1. I'm going to say 2x times x is 2x squared. 2x times 1 is 2x minus 3x minus 3 plus 2 times 5x is 10x. On the right-hand side, I got 2x times x plus 1 is 2x squared plus 2x. Then I'm going to simplify each side if there's any like terms. Okay? So on the left side, I got these 3 that are all the same. 2x minus 3x and a positive 10. So negative or positive 2 minus 3 plus 10. 2 minus 3 plus 10. 9x. Oops. So I have 2x squared plus 9x minus 3 equals 2x squared plus 2x. Because it has an x squared in the problem, my first inclination for solving that would be to get it equal to 0. So I need to start moving stuff to get 0 on one side. Well, I'm going to move the 2x squared, move that 2x squared right there, right? That'd be my first step. But when I do that, what happens to the 2x squareds? They end up canceling each other out, which makes this problem way easier when that happens. If the x squareds cancel out, that means, hey, I don't have a quadratic, which means I don't have to factor it. And it also means I don't have to do quadratic formula. Makes this a lot easier. Okay. So if the squareds or the exponent parts cancel out, then it becomes just a regular old equation. 9x minus 3 is equal to 2x. And all I've got to do is get x by itself. Okay. Because it doesn't have an exponent on the x, I don't have to get it equal to 0 anymore. So I could take this 9x and subtract it. And I get a negative 3 is equal to negative 7x. And one step gets it to equal to 0 or equal to x divided by negative 7. Negative 3 divided by negative 7 is positive 3/7. And that equals x. It doesn't match the excluded value. So that means that's a good answer. It means we're going to keep it. We get that original problem, the very original. Go back up here to what's written in the black letters. That original stuff written in the black letters is the original problem. And plug in 3/7 for x, and it would check in this problem. That'd be the right answer for that. So you can since we're dealing with equations, a lot of people, it's hard work. This stuff's difficult, no question. I'm not pretending it's not. But because it's an equation, you get an answer that you can take back and plug in to see if it's right. So that's why some people kind of like this a little bit better, some of the other stuff, because, hey, I get something concrete. I get an answer that I can check, which is always a plus. All right. So we get 3/7 for the answer on that one. Okay. Let's go through some more of these. One's not enough for sure. All right. So let's take example B. Let's say we had x over x minus 5 plus 5 equals 5 over x minus 5. If I didn't write it down, that'd be a confusion to call out to you to try to write. X over x minus 5 plus 5 equals 5 over x minus 5. All right. So key to this, again, is look at everything as a fraction, even if it's not written as one. I'm going to write that 5 over 1 just so I think about it as a fraction. And then I look at the denominators of all of the fractions. So I look at those and I see, hey, these don't have an exponent on x, and there's nothing in front of x, so that tells me these probably don't factor at all. So I would normally try to look at the fractions and see if they would factor, the denominators would factor at all. These don't, which is good. That means this problem's a little easier. So once I've looked at that, and if anything needed factoring, I factor it. Well, this one didn't need factoring, so that means I can go ahead and look at my least common denominator, which for this one is really not bad at all because I only have x minus 5. I got two fractions that have an x minus 5. That makes that a lot. That means, okay, x minus 5 has got to be part of that. And then the other fraction only has a 1 on it. It doesn't even have a weird number like a 4 or a 2. It's got a 1. So what's 1 times x minus 5? It's just x minus 5, isn't it? 1 times whatever you multiply 1 times, it gets it back. So what that tells me is I've got an easy common denominator. I've got x minus 5 as my common denominator. I want to find my excluded value from that. This one will have one excluded value because the factor is x minus 5. There's only one of those. So I take that common denominator, x minus 5, and I set it equal to 0. That's what you got to do to find those excluded values. Okay. That, when I solve that, I'm going to add 5. So that tells me that x cannot be 5. If I get 5 as an answer, then I'm throwing it out. Okay. I may get some other answers, but if 5 is one of the answers, then it doesn't count. Okay. It's an excluded value. The reason it's excluded is because if x was 5, I'd have 5 minus 5 on the bottom. And that's dividing by 0. And we can't do that. That's not a defined operation in normal mathematics, is dividing by 0. So that's why we're finding that excluded value. Now here's the good part on this one is it's not real hard to get the common denominator fixed on all these fractions because 2 of them already have it. So this one in the middle here is the only one that got to fix. Anybody a middle child? I'm one of 3. I'm the youngest, so I'm the spoiled one, and my brother, the middle one, we always said he was the one we had to fix. So the middle one's got to be fixed. No offense if you're a middle child, or maybe you understand if you are a middle child. My brother does. He does now anyway. We have a lot of fun with him. So all right, so it already had the 1, so it needed the x minus 5. So we multiply top and bottom times x minus 5. That allows us to then do the numerator equation. Okay, remember because we got the excluded value over here, we can drop the denominators, which makes this look a lot easier. Okay, so we're doing all the work so that we can get rid of the denominators, and all we've got left is this equation right up here. That stuff there, which is x plus 5 parentheses x minus 5 equals 5. Okay? The numerator equation. That's what we're trying to work. And then we're just going to solve this equation. And this one's not a bad one to solve because, I distribute the 5. X plus 5x minus 25 is equal to 5. And I don't see an exponent on the variable. So that tells me, hey, I don't have to get it equal to 0. I'll just solve it like normal. That's all I got to do. So I'm going to add those two together. That's going to get me 6x, right? Minus 25 is equal to 5. And now what's the next step to solve that? Good job. 25 added to both sides. 6x is equal to 30. And the very last step, divide by that 6. 30 divided by 6 is, that matched my excluded value. What does that mean I do with it? Throw it out. That's not an answer. Because it matched my excluded value, I throw it away. I don't have another answer to fall back on. So what's the answer to this? No solution. Because the only answer I was able to find matched the one it can't be. That means it's no solution. If I had solved this and maybe had a quadratic there and I had two answers and one of them was an excluded value and the other one wasn't, I'd still have one answer to fall back on. This one I only found one answer. It happened to match my excluded value, so I know that this equation has no solution. Okay, because those matched up. All right, let's look at another one. Practice is the key to this stuff. There ain't no question. All right. Let's look at x minus 5 over x minus 3 plus, that's a 3 right there, 3. 1 over x is equal to negative 7 over x squared minus 3x. All right. So we have three fractions in this one. We don't have to fix any of them to make them look like it. So we've already got three fractions. I checked the denominators to make sure they're all in descending order. So I got x minus 3, that's okay. Plain x, that's okay. X squared minus 3x. They're all already in descending order. The next step would be try to factor any of them that can be factored. Well, x minus 3, this first one, that can't be factored at all because there's nothing going on there, no GCF or anything. Plain x, so that's too plain to be factored. But x squared minus 3x, there's a GCF there, which is what? X, yeah. And that would leave us x minus 3 in the denominator. So the denominator for the third fraction is actually x times x minus 3. So now when I go to look at my least common denominator for the whole problem, what is shared with these fractions? Well, there's an x. There's two factors on this third one. So I'm going there first. I see an x. Well, that's shared with this fraction. So that must be part of the common denominator. There's an x minus 3. That's shared with this fraction. So that's got to be part of the common denominator too, right? X times x minus 3. Well, now that takes care of everybody that's in this fraction. And everybody here is taken care of too. So there's my common denominator. I got two factors, x and x minus 3. So I'm going to find my excluded values. By setting x minus 3 equal to 0. That's already factored. So what do I do with each factor? I set them equal to 0. X equals 0. X minus 3 equals 0. Well, there's one of my excluded values. X can't be 0. Plus 3, plus 3. X can't be positive 3. I've got two excluded values for this problem. 0 and positive 3. If either of those is an answer, then I throw them out. Okay. Now, let's go back to the problem that we're supposed to be solving. What does the first fraction need to get the common denominator? It has the x minus 3, so that means it needs the x. Times x on both top and bottom. Okay. The second fraction has the x, so that means it needs what? It needs the x minus 3. Top and bottom. The third fraction already has both of them, so it doesn't need anything. Okay, so we're going to leave it a negative 7. Now, I've done all the work so that I can just do the numerator equation. Just the top part's the only part I've got to work now because I did the excluded value stuff for the denominator. So I'm going to work that part. X parentheses x minus 5 plus 1 times parentheses x minus 3 is equal to negative 7. Okay. Now, distribute. Anywhere there's a distributive property, you want to do that and so that you can start putting like terms together. So I'm going to distribute the x here. So x times x is x squared minus 5x. And distribute the 1 here. That's a positive 1 because it has a plus sign in the front. So positive 1 times x, positive x or positive 1x. Positive 1 times negative 3 is negative 3. And then there's the negative 7 over there. Look to combine like terms after you've done all the multiplication. We're doing order of operations here. So parentheses, exponents, multiplication, division left to right, and then addition, subtraction left to right. Before we start solving, we got to do all that stuff. So putting those things together in the middle there, we got x squared minus 4x minus 3 is equal to negative 7. With this one, I see that it has an x squared in it, and there's not another one over here to cancel it out with. Anytime we have an exponent on the variable and it's not going to cancel out, we've got to do the work to get the problem equal to 0 so that we can either do quadratic formula or factoring to solve it. Have to get it equal to 0 anytime there's an exponent on the variable. If it doesn't have an exponent, we just solve it for x. Because it has an exponent, we're going to have to get it equal to 0. So that's easy on this one. You just add 7. X squared minus 4x plus 4 equals 0. And here's where you make a choice about how you solve it. If you're really good at quadratic formula, use it. It's absolutely fine. If you're better at the factoring method, this one factors. You can use the X method for factoring on this one. It doesn't matter. If you do it correctly, you're going to get the same answer either way. Okay? So if I set this up and do the X method of factoring, 1 times 4 is 4. Negative 4 goes on the bottom. That'd be negative 2 and negative 2. Negative 2 times negative 2 is multiplying to be positive 4. Negative 2 times negative 2 adds to be negative 4. So that's the right numbers for that. And then I'm going to take that and because there's a 1 in front of x squared or nothing there, I can go x minus 2 equals 0. Shortcut on the factoring. That's why I did factoring instead of quadratic formula, because I knew I could, if it factored, I could do a shortcut. And then set each of those equal to 0. Both of them going to get x equals 2, which is not an excluded value. So that means they're both answers that we're going to keep for this problem. Happen to be the same number twice, and that's okay. So x equals 2 is the answer to this problem. And we have excluded values of 0 and 3 out of that, which didn't match those. So that means we don't throw them away. All right, let's try another. They're not going to get just crazy difficult on these, because even the simplest ones, like none of them that we've done so far have been really difficult ones, but they still take a while. So they're not going to get just crazy polynomials on you here for this. So don't get thinking you're going to get one of those x to the 5th power problems like we did in 100 to solve here. They're not going to get that crazy with it because it does take so long to just do one of the easier problems even for this. So let's take this problem. Say x over x plus 5 plus 5 over x minus 5 equals 50 over x squared minus 25. Better yet, let's change that number from the 50 up top. Let's change it to let me change it. I want to change the answers on this, and this one doesn't work out real great. Let's change it to 74. 74 instead of the 50. Well, x over x plus 5 over x minus 5 equals 74 over x squared minus 25. All right, so not too bad here. You got some plain stuff on two of the fractions. You got x plus 5 and an x minus 5. So there's nothing to do with those two. But the x squared minus 25, that third fraction has got an x squared on it. So that makes me think, hey, I could probably factor that some way, shape, or form. And the good news is that's a difference of squares. That's x squared minus 25 is 5 squared, right? So that can be factored. X plus 5 and x minus 5, which, aren't we lucky, are the same pieces that were underneath the other two fractions. That kind of nice to us about that. Now we get the common denominator. That's the key to this problem. Any fraction equations, the key is common denominator. So least common denominator. Well, we'll look at the denominators. We got x plus 5, x minus 5, and then this one has both of those. So we know it should be both of those, right? This one shares the x plus 5 with the third fraction. The x minus 5 is shared with the third fraction. So both of those have got to be part of that problem. And then we can get the excluded values. By just taking x plus 5, x minus 5 equal to 0. And it's already factored, so we know that we're just going to take x plus 5 equal to 0, x minus 5 equal to 0. And there we get negative 5 and positive 5. Those are the things x cannot be. If we get one of those as a solution to this problem, then we throw it away. So that is what we got to do. Okay. Now, go back to the original, and let's fix up the denominators. The first one has the x plus 5, so that means it needs the other one, x minus 5. So top gets the x minus 5 too. Second fraction has the x minus 5, so that needs the x plus 5, top and bottom. Okay. Because I've now got the denominator the same, all I'm going to work with is the numerator equation. Okay. Numerator equation is what I'm working with, which is x parentheses x minus 5 plus 5 parentheses x minus 5 plus 5, excuse me, and then equals 74. Distribute everywhere that there's a distributive property to do. X squared minus 5x plus 5x plus 25 equal to 74. Combine any like terms that there are. You got a negative 5x and a positive 5x. What happens to those? They cancel each other out. That's nice. X squared plus 25 is equal to 74. And because it has x squared in the problem, I know I need to get it equal to what? 0. So I'm going to subtract 74 from 25. So 25 minus 74, negative 49. So I've got x squared minus 49 is equal to 0. Good. Difference of squares, because 49 is what squared? 7 squared. So that's x plus 7, x minus 7. And set those equal to 0. X equals negative 7. There's an answer. X equals positive 7. There's an answer. Okay. That doesn't match one of our excluded values. That's why I changed that number to a 74. What I had before matched those, and I didn't want it to be a no solution again because we already seen that. So process of this is the same. Factor denominators, get a common denominator, get your excluded values, fix them, numerator equation. It's that every single time, okay? The last section is just an extension of this. And I'm gonna do it now. Let's go ahead. It's just 2 more examples. You guys can hang with me for 2 more examples, I think. And section 1.7 is rational inequalities. Rational inequalities, okay? The only big difference in doing these compared with doing equations is that the first thing you want to do is get 0 on one side. That is the first step in a rational inequality, okay? The inequality idea starts opening up the idea that you have more than single answers. You have a group of answers that are on a number line. And with rational inequalities, it's very similar to when we did quadratic inequalities back in Math 100. It is almost exactly the same thing once you get the polynomial set up. But with inequalities, when you look at fractions, it's very difficult to look at a fraction that has variables in it and decide if it's greater than or less than another number because it has variables in it. But it's pretty easy to decide if it's positive or negative. And so if we get a 0 on one side, if it's greater than 0, it's positive, right? If it's less than 0, it's negative. And that's easy to determine. So one of the things that we're doing here is first getting it set up and easier to solve, but it's also getting it easier to compare to 0. It's much easier to compare to 0 than it is to compare to some other number. If we're having to check if something is greater than -4, then that means it's got to be, it could be -3.9, and that's bigger than -4. But we've got to be a lot more careful. If it's greater than 0, hey, it's just got to be positive. We don't really care what the number is. It's much easier to compare. So the comparison that we have to do for the rational inequalities is much easier to do if you'll get it equal to 0 first. So let's start with an example that they're not going to get crazy hard on the polynomials that are involved just because it takes a while to do this anyway, and you've got a little bit of an extra step here because it's an inequality. So let's take just 6 over x minus 3 is greater than or equal to 4. Real simple one to start off with. But the first step is to get it with a 0 on one side. And if one of the fractions doesn't have variables and stuff, that's the one I move. I'm going to move the 4 by subtraction because that's the easiest way to get a 0 on one side. And then we have 6 over x minus 3 minus 4, and I'm going to put that 4 over 1 so it looks like a fraction. Okay. And then I'm looking at this left-hand side and I'm saying, okay, that's a fraction subtraction problem, so it's got to have a least common denominator. And because x minus 3 is the only thing that's got anything going on, that means x minus 3 is the common denominator. And if we set that equal to 0, We know x can't be 3. We know that off the bat, that that's an excluded value. X can't be 3 right off the bat. The next thing to do is fix the denominators. The first one already has x minus 3. Second one needs it. So top and bottom get it. And then we're looking at that and we're saying, okay, well, that's going to be 6 minus 4 parentheses x minus 3. On the right-hand side, having a 0 over there just means I don't have to do anything to that, because no matter what I multiply times 0 on that side, it's 0. So then I'm going to solve this inequality. It's the numerator inequality now instead of the numerator equation. At this step, everything has been, except for moving it and getting 0 on one side at the beginning, it's the same as what we were just doing. Nothing's changed. Okay? So I'm going to take that. I'm going to solve it. So that's going to be 6 minus 4x plus 12 greater than or equal to 0. And then I'm going to get the like terms together. Got 6 and a plus 12. So that's negative 4x plus 18. And then it doesn't have an exponent on the variable. So that means I don't have to do anything special here. I just get x by itself, which works out wonderfully. Subtract 18. Negative 4x is greater than or equal to negative 18. And then I divide by the negative 4. And when I divide by a negative with inequalities, what do you have to do? Change the sign to a less than or equal to. And then that'll be positive 9 over 2. I'm going to leave it as a fraction. There. All right. Now, what that tells me is I've got to check some things about 9 over 2. Okay. So here, remember when we did the quadratic inequalities, we set up a number line. And we put our answers on the number line. With this, we've actually got 2 different numbers that are affected here. One of those numbers is the 3. Right? Because x couldn't be 3 was an excluded value. 9 over 2 is 4.5, right? We all know that. So at 3 and then 9 over 2. So we had any excluded value we've got to take into account. We know it cannot be 3, so we're going to put an open circle on that. But we have an equal to mark on the 9 over 2, so we're going to put a filled in dot there. Okay. There are 3 sections to test. We got this section here that's from negative infinity up to 3. This is from 3 to 9 over 2 bracket. And this is from 9 over 2 to positive infinity. Those are the 3 areas that we need to test in. So what we're going to do is we're going to plug that in and pick a number from that area and plug it in. So in this first area, if x were 0, would it be between negative infinity and 3? Yeah. So that's a good test number for that area that I can test 0 in the problem. I'm going to go and I'm going to test that in my problem here. 6 over x minus 3 minus 4. 6 over 0 minus 3 minus 4. My question is that greater than 4? I mean, greater than 0. Greater than or equal to 0. Because I'm going up here to this inequality that I made. Because it's easy to compare to 0 instead of comparing to 4. So 6 over negative 3 would be negative 2 minus 4 is negative 2 minus 4. That's negative 6, right? Is that greater than or equal to 0? No, that's false. So I know that part is out. That's not an answer. because -6 is not greater than or equal to 0. Okay. 0 is in, I used x equals 0 because it's in that window right there. It's from -infinity up to 3. It's in there, and it was easy to plug in. Now I need something that's between 3 and 4.5. What's a good number that's between 3 and 4.5? 4. So I'm going to plug in 4 for x. So I have 6 over 4 minus 3 minus 4. I'm testing, is that greater than or equal to 0? Well, that'd be 6 over 1 minus 4, which is 2. Is 2 greater than or equal to 0? Yeah, that's true. So that means this area here is true. That means it's an answer. That doesn't mean that could be the only area. We've got another spot to check. We've got to check here at 9 over 2 to infinity, because this whole thing here, this part of the arrow, the whole thing could be an answer, but it may not be. So we need a number that's bigger than 9 over 2. 5. 4.5, something bigger than 4.5 is 5. So I'm going to plug a 5 in to my problem. 6 over 5 minus 3 minus 4, is that greater than or equal to 0? I'm checking x equals 5. So that'd be 6 over 2 minus 4. So that'd be 3 minus 4 is -1. Is -1 bigger than 0? No, that's false. So this area is also false. Okay, so it's out. So that means my solution is from 3 to 9 over 2 bracket, because that was the only one part that was true. Test points at the end are the critical part of this. All the other part is rational stuff. It's just like the equations. The test points at the end are key, okay, to solving this and finding out which parts work and which parts don't work. Okay. All right, let's do another one. See if we can get an idea about what's going on here. And then we'll finish up for the night. All right, so we got, let's take 3x plus 1 over 2x minus 3 plus 3 is less than 7. So here's one that looks like it could be complicated because it's got 3 parts to it. We see it's a rational inequality. So that tells us right at the beginning, because we see a fraction with x's in top and bottom, that we need to get 0 on one side to start off. Before we do anything else, just get a 0 on one side so that's easy to test on. So we're going to subtract 7 from both sides. That's the quickest way to get 0. It's not the only way, but it's the quickest way. 2x minus 3. And then that would be minus 4 is less than 0. Just a less than symbol here. No equal to symbol on this one. So that means we won't have any brackets in our answers at all, because there's not an equal to mark. So there's no way that a bracket could appear. Now, next thing to do is get a common denominator. And because this 4 is over 1, then we know that the common denominator is just going to be 2x minus 3. And our excluded values, I'll abbreviate that, EV, comes from setting 2x minus 3 equal to 0. Add 3. Divided by 2. X cannot be 3 over 2. So we know when we set up our number line to do this, we know a 3 over 2 is going to be on there somewhere. Okay? I know what else comes, but so I know it's going to be there. So I know a 3 over 2 is going to have an open circle on it because it can never, can't be there. Can't be that answer. Now I need to go over here and fix this problem. So I need a 2x minus 3 on the second fraction. Again, they're not going to get too difficult on the inequalities because it is a long process anyway. And then so we're going to take 3x plus 1 minus 4 parentheses 2x minus 3 is less than 0. Plug, work that out. So 3x plus 1 minus 8x plus 12 less than 0. We'll solve that. So I got 3x minus 8x negative 5x. 1 plus 12 is 13. I'm just putting like terms together is all I'm doing there. 2 more steps to get my other number. Subtract 13. Divide by negative 5. I divided by a negative again, so that's going to make me flip the symbol. Get x is greater than 13 over 5. So 13 over 5 would be to the right of 3 over 2. And it's greater than, so I know it's an open circle out of that. So what I do is I think about the intervals on that number line. I know that this is negative infinity up to 3 over 2. And I know that this is 3 over 2 to 13 over 2. And this is 13 over 2 to infinity. Those are the intervals where I've got to pick test points from. Okay. And I'm going to test them in the problem. 3x plus 1 over 2x minus 3 minus 4. I'm going to test in this problem. And that helps kind of clear this up here. So I need some test points. So I need a number that's between negative infinity and 1.5. That's easy to plug in. I'd say 0 or 1. Either of those would both equally be easy to put in. I'm going to put a 0 in. So I'm going to test x equals 0. So 3 times 0 plus 1, 2 times 0 minus 3 minus 4. So that's going to be negative 1/3 minus 4. Negative 1/3 minus 4 is a negative number, right? It's going to be more negative than it already was. Is that less than 0? That's negative 13 over 3. That's less than 0. So this area is true. So that's going to be part of our answer. Right now we know that everything from here that way is part of my answer. But I've got 2 other little windows that it could be in as well. So I got to pick some test points from there. So I'm going to test a number in here between 1.5 and 6.5. 2 is a good number that's between there. 5, any number you want to pick that's between 1.5 and 6.5. I'm picking 2 because it's the smallest one that works. Okay. And plug that in. 3 times 2 plus 1 over 2 times 2 minus 3 minus 4. So that'd be 6 plus 1 is 7 over 1 minus 4. That's 3. Is 3 less than 0? Oh, that's false. 3 is not less than 0. So that middle part is out. It's not part of the answers. It's possible that the third part could also be thrown out. But it's also possible that it could be true. So I need to test something that's bigger than 6.5 and between 6.5 and 100. 7 is a good one. It's bigger than 6.5 and it's the smallest one to plug in. If you want to use 10 because the math's easy, that's fine too. Okay. So I'm taking 7 and plugging it in. So I'm going 3 times 7 plus 1, 2 times 7 minus 3 minus 4 is less than 0. So 3 times 7 is 21 plus 1 is 22. 2 times 7 is 14. 14 minus 3 would be 11. So that'd be 2 minus 4 is negative 2. Is negative 2 less than 0? Yeah, it is. So this part's true as well. So our answers are both ends of that inequality, of that number line for this inequality. So our answers would be solutions from negative infinity up to 3 over 2, because that's what I was on, union 13 over 5. Hold on. That's supposed to be 13 over 5, not 13 over 2. The numbers I picked still work. 13 over 5 to positive infinity. That's the solution sets for this particular rational inequality. Okay, rational inequalities, again, not going to be just incredibly difficult on that, but they're not going to be, there's a lot of steps to them. It's not a short process, but they're not going to be really huge polynomials that you got to solve. And the key is getting the inequalities, get those, get a 0 on one side so that you can compare really easily and quickly. Okay. Problems from 1.6, there's 1 through 25. From 1.7, 69 through 91. Any of those problems, not a whole lot from those two sections that you could do. I will post videos and links to that, and what quizzes and labs go with this stuff. And we will meet again Thursday, 4 o'clock, and go from there. Just a reminder that on July the 25th, which is next Thursday, we will not have class next Thursday, but we will have class this Thursday and next Tuesday. Okay, so if you got questions, email me. If something isn't working right on Canvas, email me. Let me know, and I can usually fix that in short time there and get you going. Okay. You guys are dismissed. Have a great night. See you on Thursday.